So I was explaining about operating system as part of this, as an example of system software. And I said it is acting as an interface between software and the computer hardware. It is in between the application software and the computer hardware. So the main key objective of operating system is to make sure computer systems are convenient to use in an efficient manner. Also, to hide the details of computer hardware from users. Remember, users interact with applications. Then the applications sit on computer system software. Then system software sit on top of computer hardware. So in short, it is hiding the details of the hardware from the users, providing users a convenient interface to use the computer system. Acting as an intermediary between the hardware and the users. And remember when I introduced, I said it is a software which is in between. When I say intermediary, it is in between the applications and the computer hardware. Keeping track of which resources, granting resources to users as requested, and also acting as a mediator between conflicting requests from different programs and users. Remember, there are other times which several people are using actually one machine when we are talking about in multitasking environment. So this aspect of ensuring which resource or which program is able to access the processor is also done by operating system. So in short, we are saying it provides an efficient and a fair sharing of resources among users and programs. Those ones are the key primary objectives of operating system. So this is the diagrammatic view of this, which tries to summarize or tries to reflect where this system software or where this operating system comes in. So I hope you have seen where this operating system comes in. So characteristics of this operating system is that one, it does memory management, which is keeping track of primary memory. Which part of the primary memory is in use by whom and what part is not in use, including also allocating the memory when a processor or a program requests it. You see, there's also processor management, allocating the processor. So that aspect of which process should access the processor. Remember, the user activities are now known as processes. So which user activity accesses the processor is an aspect within the operating system. It is the duty of operating system to schedule that. There is also device management, keeping track of all devices, or what we say I/O control. And I want to say that the mouse, for example, which you know it's an input device, is not detected or is not known to your computer. It is only and until when you have installed the operating system that your machine can now detect a mouse. You see, there's also file management, security. The way you configure a password in your machine or your PC is within, it is inbuilt. That security module is actually part of operating system. There is also job accounting, keeping track of who accessed the system at what time and accessed or used which kind of resources. So that security mechanism is within the operating system. There is also control over system performance, interacting with users, error detecting, and many, many, many others. So when you have an error within your machine, an ability of your machine to recover from errors is because of this error detecting aids can give you possibly what could be the problem with connection. For example, if you are talking about internet connection, it allows, for example, to discover what could be the possible errors and maybe also recover automatically from those errors because of those error detecting aids. So it offers you diagnosis of what could be possibly the error and coordination between other software and users. So that is generally what we mean by operating system. Now, just to summarize this software, I would want to explain a little bit about open source and proprietary software. So open source software is a category of softwares which are free. When I say open source, I mean free software, which is under general public license, or what we say GPL. There is also proprietary software on the other hand, which we mean software which are commercialable software, which is owned by a company. So it is somebody's property, and you must pay for license to be able to use those products, like the ones for Microsoft. When you want to install MS Office within your machine, then you need to pay because it is a commercialable software. Now, examples of open source software include Linux and its distros or versions. So we have one, for example, in Linux, we have distros such as Backtrack, Debian, Ubuntu, Kali Linux, and many others. Those ones are examples of Linux operating system. There is also Android, which you normally use in your phones. Android is also open source. Now, when we go to the other side on proprietary, you know Windows. The Windows operating system that we use is proprietary. It is a paid software. You must pay Microsoft to use it. It is not like Linux. Linux is free. You just install and use it in your machine. So examples of Windows operating systems include, we have DOS, we have XP, we have Vista, Windows Vista, we have also Windows 7, we have also Windows 8.0, Windows 8.1, Windows 10, and many others. So I just wanted you to distinguish between open source software and proprietary software. Open source to mean free and proprietary to mean commercialable or somebody's property in other regards. So that is it about the operating system. Now, there is the other bit on computer hardware. So maybe just to make a basic introduction into computer hardware. So I want to say that hardware is the tangible components of a computer. What you can see, the physical components. And we categorize this hardware into input devices, which we have covered before, the keyboard, mouse, and many others. Output devices, which we have covered, printers and monitors. Secondary storage devices, such as hard disks, which are found within your PCs, the compact disks, and digital versatile disks or DVDs. There are also internal components such as the CPU, the motherboard, and the RAM, which are some, these are components which you have come across. Maybe just to make, we will be able to explain more on the computer motherboard. So maybe to make a relationship between the hardware and the software. So the hardware and software are mutually dependent of each other. Remember when we saw from the diagrammatic representation, we saw users, followed by applications, followed by the system software, then the computer hardware. And you can see the system software is sitting on top of computer hardware. That is why we are saying they are dependent on each other. Software cannot be utilized without the supporting hardware, because you must install the software on a machine. So you, at the end of the day, you need the computer hardware to be able to install the software. That's why we can say software cannot be utilized without supporting hardware. So hardware without set of programs to operate upon cannot be utilized, and it is useless. So we can agree with that. So hardware is one-time expensive, because the cost at which I need to acquire a computer or a laptop is very expensive. But subsequently, you realize that these costs tend to outweigh, the benefits outweigh the cost in long run. So it is only expensive once, but once I have the hardware, I can be installing software or any other software that I want. So those are some of the aspects. The others you have gone through, like software acts as an interface between the user and the hardware. And I said it is coming in between the users and the hardware. And you saw the two softwares, application software and system software, that they are coming in between the users and the computer hardware. So you will be able to read more on the relationship. Now, this takes me to the motherboard. As part of this hardware, we have something known as a motherboard. And I want to put it very clear that a motherboard serves as a single platform connecting all parts of a computer. Whatever makes a computer hardware is actually the motherboard. This is where all the components get attached. All components in your PC or your laptop is attached to this thing known as a motherboard, serving as a single platform where all parts of a computer together are combined. So the hardware, optical drives, video cards, sound cards, ports, expansion slots, cables are all considered being part of this computer motherboard. So this is a diagrammatic representation of motherboard, and you can see this is the RAM slots where we have the RAMs. This is the fan, the ROM chip, ports, and the others, expansion slots. So the motherboard varies considering the different manufacturers. So you realize that there are a number of manufacturers of motherboards, such as Intel, one of the popular companies manufacturing computer motherboards, Abit, Biostar, and many others. These are the popular manufacturers of computer motherboards. And the motherboard ranges from different manufacturers. So, but there are general aspects, like each and every motherboard must be supporting a single type of CPU or few types of memories. Any other motherboard must have video cards, hard disk, sound cards, and many others. So what we normally say is that the different motherboards, like the standards might be varying a little bit considering the manufacturer. So that if you have a memory or the RAM slots there, you realize that the RAM slot might not be similar with the other manufacturers. That's why you can say that I cannot just get a RAM chip and just put it there. It must be compliant with the motherboard or the manufacturer's requirements so that it can be able to fit within the motherboard. So you should be able to read on the motherboard. So I would not want to continue much. So I'll pick in the next class on ports. I'll just pick from ports, computer ports. So that is it for